Hello and welcome to this video on annuities. An annuity is a series of payments, usually in equal amounts, that are made at regular intervals for a fixed period of time. Consider an example where Dustin paid off their student loan in 4 years by making payments of $350 at the beginning of every month. The interest rate of their loan was 5.40% compounded monthly. We need to first calculate the size of the original loan and round the answer to the nearest cent. And second, calculate the amount of interest paid on the loan and round the answer to the nearest cent. The series of equal deposits that Dustin makes at regular intervals for a fixed period of time is called an annuity. When we have a problem on annuities, it's important to classify the annuity and to identify variables involved in the problem. The annuity we are talking about here is an annuity due because payments are made at the beginning of each payment period. Here, the payment period is monthly. Let's write payment period is monthly. And we have that the compounding period is also monthly because what we have here is that interest is compounded monthly. So this is an annuity due that is simple. So the first thing we can say is that we're working with a simple annuity due. Okay. And when we work with a simple annuity due, there are certain formulas we work with. We need to keep in mind. One of the formulas tells us that the future value of an annuity due, of a simple annuity due, is given by certain expression. We have the formula future value equals PMT times 1 plus I to the n minus 1 over I times 1 plus I, where PMT is the amount of the periodic payment of the annuity and is the total number of payments during the term of the annuity, and I is the periodic interest rate, the interest rate per compounding period. And the other formula that is relevant when we work with a simple annuity due is present value of the annuity equals PMT times 1 minus 1 plus I to the negative n over I, and then times 1 plus I. This should be a 1 plus I, all right, where PMT is the amount of the periodic payment of the annuity, I is the periodic interest rate, and N is the total number of payments during the term of the annuity. Now, in the problem we have here, in part A of this problem, more precisely, we need to calculate the size of the original loan. The size of the original loan corresponds to the present value of the annuity. So between the two formulas we wrote, we choose to work with the second formula, the one on the right, the one I just boxed, because we need the present value of the annuity. So let's erase the formula for future value and let's focus on the formula for the present value of the annuity. All right. Now, in this formula for the present value of the annuity, so we're working in part A, we need to identify the amount of the periodic payment of the annuity. And the amount of the periodic payment of the annuity is $350 because Dustin pays, or better paid, that amount at the beginning of every month. Another number we need is N. N is the total number of payments during the term of the annuity. The term of the annuity is usually denoted by T. In this case, we have 4 years because that's the time from the beginning of the first payment interval to the end of the last payment interval. Now, based on that value for T, the total number of payments during the term of the annuity is the number of payments per year multiplied by the time period in years. So we have multiplied by T. Because Dustin made payments every month, the number of payments per year is 12. And then the number of years is 4. So N equals 48 in our problem. Next, to find I, the periodic interest rate, we use the nominal interest rate, that's 5.40%, or 0.054 if we look at the decimal version of 5.40%. And we look at the compounding frequency. Because interest is compounded monthly, the compounding frequency is 12. So the periodic interest rate turns out to be J divided by 12. We do J divided by M. So we divide 0.054 by 12, and we get whatever we get. With the values of P, M, T, N, and I, we can say that the size of the original loan is the present value of the annuity due, and that is $350 multiplied by 1 minus 1 plus 0.054 divided by 12 to the negative 48 divided by 0.054 divided by 12, all that multiplied by 1 plus 0.054 divided by 12. Okay. And when we use a calculator to compute this value, we want to use an expression like 350 times, then bracket, 1 minus bracket, 1 plus 0.054 divided by 12, close bracket, raised to the bracket minus 48, close bracket again, divided by open bracket 0.054 divided by 12, and then close bracket. Okay, and then close bracket again, and then multiplied by 1 plus 0.054 divided by 12, and then close bracket. So just be mindful of all brackets we need to use when we work with a calculator. And a calculator would give us the answer $15,146.96 when we round the answer off to 2 decimal places. So we get 15,000 $146.96 as the size of the original loan. All right, let me erase what we have here. Okay. Now, regarding part B of this problem, we want to calculate the amount of interest paid on the loan. And to find that interest, we use a formula. Interest paid on the loan equals, and when we're working with the present value of an annuity, we have n times PMT minus the present value of the annuity. So we're doing 48 times PMT, and PMT is 350. Take away $15,146.96. And when we do that subtraction and round it off to 2 decimal places, we get the number. This means approximately equal to. This means approximately equal to 1,653.04. So therefore, the amount of interest was about $1,653.04. All right. Okay, so that's it for this problem. We can summarize what we did in various parts. The first thing we did was we classified the annuity as a simple annuity due. Then we said that there were 2 formulas that were particularly important with simple annuity due, with a simple annuity due, and because we were interested in finding the original size of the loan, then we figured that we needed to find the present value of the annuity. Then we chose this formula right here to work with. Then we identified PMT, the amount of the periodic payment, N, the total number of payments during the term, and I, the periodic interest rate, to find the present value of the annuity. And the answer to that part, the present value of the annuity, was the answer to part A. And then to answer part B, we computed the subtraction between the total amount of money that was paid and the present value of the annuity. So we did 48 times 350 minus what we found for the present value of the annuity, and we got $1,653.04. Okay. All right, then if you have questions, please write a comment or contact me and I'll try to help you. Thank you for watching. Bye bye.